Okay, so let's have a look at this. Let's have a look at this reaction. We've got this stuff, decane, and it's turning into ethene. Now we can tell it's got a double bond in because it's the ratio of hydrogens to carbons is CnH2n, yeah, and one molecule of ethane, and that is CnH2n plus 2, so that hasn't got a double bond in it. So we're getting this big long hydrocarbon molecule, break it into smaller ones. Some of them got double bonds in them, and you might recognize that as being a cracking reaction. Okay, so we want to find out, and what we want to do is we want to find out delta H for this reaction. We can't measure that directly, as we said before. You can't get a copper can with a thermometer in it and get C10H22 and expect it to break down by itself. You'd have to heat it up loads, and then you wouldn't know whether the heat going into the copper can, is that coming from what you provided or is it coming from the reaction? So you can't do it directly. I'm sure you can appreciate that. So you've got to do it indirectly and using Hess's law, which we looked at in the last video, which is really just the conservation of energy. Whatever route you take, it doesn't really matter what route you take. It's the start point and the final point, and that's the only thing that affects the enthalpy change, delta H, for that reaction. So they're giving us delta HC values there. So what we did in the Hess's law cycle, you always need a third thing down here somewhere. And what we're going to put down in there, this delta HC, is we're going to put the combustion products. When you burn all that stuff, what you get carbon dioxide and water. You're going to get 10 carbon dioxides and 11 waters. Just tidy that up a bit. 10 CO2 and 11 H2O. Put a box around it. Okay. So, and we're going to need some oxygen to do that as well. So let's put this. This one's easiest first. Let's do that arrow. What we're doing there, we're just burning one molecule of decane, 1 mole of decane, and look at the value over there. It tells us it's minus 6,768. So let's write that down there. Minus 678. And let's look at this one here. So we are going, so this arrow here, what we're doing there, well, we're burning 4 moles of ethene, and each ethene, you'll get this much out when you burn 1 of ethene, so there's 4 of them. So I've got to put 4 times minus 1411. Don't forget the minus sign tells us exothermic. And we're also burning 1 ethane as well, aren't we? And that's 1560. So minus 1560. So I've got to add all that up together, and I'm not doing it in my head. I did it earlier in my calculator. Is minus, so okay, that's what it is. Okay, it's that value there. Okay, oh, actually, I'm going to do that in a different number. I'm going to do it in purple because I think I did it in purple last time. Minus 7204. Now, Hess's law says, right, if we start off here and we go round and finish here, that's going to be the same energy change if you just did the quick way. Okay, and so we could do red delta H plus purple delta H is equal to yellow delta H. We're not going to do that because we do the way that most people do it, sort of a bit of a cheating way, which is a shortcut. We say, right, look at the red one. We want to go from there to there. So we're following the yellow arrow, so that's good. We do that. Don't need to change the sign. But we're going against the purple arrow, so there we have to change the sign. So if we want to do what delta H is, delta H is equal to minus 6778, and I'm going to change the sign here. This was a minus, so I'm going to turn it to a plus 7204, and that is going to be equal to, I didn't do that one earlier, so I'll have to do it on my calculator. plus 426 kilojoules. Now, it's usually a good idea when you're doing these sort of calculations, if it is positive, to put the plus in. You don't have to, you won't lose marks if you don't, but just remind you that it's there. And so this tells us that this is an endothermic reaction, positive. And we knew that already, didn't we, that cracking is going to be an endothermic reaction. Right, so that is how you can use delta HC to work out the enthalpy change for a reaction, which otherwise it would be impossible to do it.